Hello there. Welcome to Akaan.
In today's meditation session, we will be taking a journey into the cosmos. I'm so glad you've chosen to spend this time with me tonight. Perhaps you've had one of those days where your mind just won't settle, where thoughts keep spinning like leaves caught in an endless wind. Or maybe you're someone who finds peace not in silence, but in the gentle whisper of scientific wonder. Either way, you've found exactly where you need to be. Tonight, we're going to do something a little different. We're going to let science become our meditation, allowing the vast mysteries of our home galaxy to quiet the noise of daily life. You don't need to do anything except breathe slowly, let your shoulders drop, and allow your mind to drift along with me through the most beautiful structure in our local universe. The Milky Way isn't just our cosmic address. It's a living, breathing river of starlight that has stories to tell, secrets to share, and wonders that can transform how you see your place in existence. As we begin this gentle exploration, I want you to imagine stepping outside on the clearest night you've ever experienced. No city lights, no pollution, just you in the infinite darkness above, that pale ribbon stretching across the sky, that ghostly bridge of light connecting one horizon to the other. That's our galaxy seen from within. We live inside this magnificent spiral, floating in one of its quieter neighborhoods, watching its glow from the inside out. But what exactly are we looking at when we gaze up at that celestial river? We're seeing the combined light of hundreds of billions of stars, each one a sun like ours, many hosting their own families of worlds. We're witnessing the accumulated radiance of stellar nurseries, where new suns are being born at this very moment. We're observing the afterglow of ancient explosions that scattered the building blocks of life across space and time. In that gentle arc of light lies the entire story of cosmic evolution, written in wavelengths our eyes can barely detect. The Milky Way is far more than just a collection of stars scattered through space. It's a dynamic, evolving system with its own rhythm, its own patterns of growth and change. Like a vast cosmic organism, it breathes through cycles that span millions of years. Gas flows inward toward the center, feeding the formation of new stars. Energy flows outward from those same stellar furnaces, heating and sculpting the space between worlds. Everything is connected in an intricate web of gravity, magnetism, and motion. Our galaxy stretches roughly 100,000 light years from edge to edge. To put that in perspective, light from the most distant stars in our galactic family takes 100,000 years to reach us. When that light began its journey toward Earth, our ancestors were just learning to control fire. The photons hitting your eyes tonight, when you look up at the Milky Way, have been traveling longer than human civilization has existed. You're literally seeing ancient light, witnessing the galaxy as it was when our species was taking its first tentative steps toward consciousness. The structure we call home is a barred spiral galaxy, meaning it has graceful arms that curve outward from a central, elongated hub. These arms aren't fixed like the spokes of a wheel. Instead, they're more like waves in a cosmic ocean, patterns of density that sweep through the stellar disk, compressing gas and triggering bursts of star formation. As they pass, the arms light up with the blue-white glow of young, massive stars, creating the beautiful spiral pattern we would see if we could somehow step outside our galaxy and look back. But we can't step outside, and that's part of what makes our position so unique. We see the Milky Way from within, like inhabitants of a vast city trying to understand the layout of their metropolis by looking out their windows. This inside perspective has made mapping our galaxy one of the greatest detective stories in astronomy. For centuries, scientists have pieced together clues from stellar motions, gas clouds, and distant light to understand the true shape and size of our cosmic home. We orbit the galactic center at tremendous speed, roughly 800,000 kilometers per hour. Yet it takes us about 225 million years to complete one orbit. This vast cycle is sometimes called a galactic year, and it puts our existence in cosmic perspective. Since Earth formed, our planet has completed only about 20 trips around the galaxy. The last time we were in this same position, relative to the galactic center, dinosaurs ruled the world, and flowering plants were just beginning to evolve. As we travel this ancient path, we're not moving through empty space. The regions between stars are filled with an incredibly thin but vast ocean of gas and dust, the raw material from which new solar systems are born. This interstellar medium is sculpted by stellar winds, shock waves from exploding stars, and invisible magnetic fields that thread through the galaxy like a cosmic nervous system. Temperature and density vary wildly from place to place, creating a complex ecosystem that nurtures the birth of stars and planets. The dust that drifts between the stars plays a crucial role in this cosmic story. These microscopic grains, smaller than the particles in cigarette smoke, absorb and scatter starlight, creating the dark lanes and patches we see when we look toward the galactic center. But dust isn't just an obstacle to our view. It's also a cosmic construction material, providing surfaces where atoms can stick together and form the first simple molecules. Some of these dust grains carry complex organic compounds, the building blocks of life, scattered by dying stars and carried across vast distances by galactic winds. Throughout this immense structure, gravity orchestrates a slow, eternal dance. Every star, every planet, every speck of dust responds to the collective gravitational pull of everything else. This invisible force shapes the orbits of worlds, guides the flow of gas through space, and holds the entire galaxy together against the outward pressure of its own rotation. Without gravity, the Milky Way would fly apart in a matter of millions of years, its stars scattered into the void like leaves in a cosmic storm. But gravity alone isn't enough to explain how our galaxy holds together. The visible stars and gas account for only a fraction of the mass needed to keep everything in its proper place. The rest, perhaps 5 times more mass than we can see, exists in a form we don't yet understand. This mysterious dark matter creates an invisible scaffolding that surrounds and permeates our galaxy, shaping its structure and evolution in ways we're only beginning to comprehend. At the very heart of our galaxy lies something even more mysterious and magnificent. Hidden behind veils of dust and gas, a supermassive black hole with the mass of 4 million suns anchors the galactic center. This gravitational giant, known as Sagittarius A star, influences the motion of stars across thousands of light years. Though it appears quiet now, there's evidence it was once far more active, perhaps blazing like a beacon visible across the universe. The Milky Way doesn't exist in isolation. It's part of a small family of galaxies called the Local Group, bound together by gravity and drifting through space as a unit. Our largest neighbor, the Andromeda Galaxy, appears as a faint smudge in autumn skies, but it contains nearly 1 trillion stars and spans over 200,000 light years. In about 4.5 billion years, these two great spirals will merge in a slow, elegant collision that will reshape both galaxies forever. As you rest tonight, remember that you're part of this vast, ancient, and ongoing story. The atoms in your body were forged in stellar furnaces and scattered by cosmic explosions. The oxygen you breathe, the calcium in your bones, the iron in your blood, all of it was created in the hearts of stars and returned to space to eventually become part of new worlds, new life, new possibilities. The story of our galaxy is also a story of cycles within cycles, an endless rhythm of creation and destruction that has played out for over 13 billion years. Stars are born in the cold, dark embrace of molecular clouds, vast regions where gas and dust gather under their own gravity until nuclear fire ignites in their cores. These stellar nurseries glow with the light of newborn suns, each one beginning its own journey through space and time. But stars don't shine forever. The most massive ones burn bright and fast, exhausting their fuel in just a few million years before exploding in spectacular supernovas that can outshine entire galaxies. These cosmic catastrophes scatter heavy elements across space, enriching the interstellar medium with the materials needed to build rocky planets and complex molecules. The shock waves from these explosions also compress nearby gas clouds, triggering new waves of star formation in an endless cycle of stellar birth and death. Smaller stars, like our Sun, live more measured lives, burning steadily for billions of years before gently shedding their outer layers into space. These planetary nebulae, glowing shells of gas illuminated by the hot, stellar core within, return processed material to the galactic ecosystem. Nothing is wasted in this cosmic economy. Every atom that once resided in the heart of a star will eventually find its way into new celestial structures. The Milky Way contains regions of incredible diversity, from the crowded stellar metropolis near the galactic center to the sparse outer suburbs where we make our home. In the dense inner regions, stars are packed so tightly that the night sky would blaze with thousands of suns, brighter than Venus. Here, gravitational interactions are common, and stellar collisions occasionally create exotic objects unlike anything in our local neighborhood. Moving outward from the core, we encounter the galactic bulge, a roughly spherical collection of ancient stars that formed when the galaxy was young. These elderly suns contain fewer heavy elements than younger stars, carrying the chemical signature of a time when the universe had not yet been enriched by countless generations of stellar death and rebirth. They orbit the galactic center in random directions, like a swarm of cosmic bees, their paths shaped by billions of years of gravitational encounters. Beyond the bulge lies the disk where we reside, a flattened structure where most of the galaxy's star formation occurs. This is where the spiral arms wind their way outward, marked by bright clusters of young stars and glowing nebulae. The disk is layered with a thin component containing the youngest stars and gas, and a thicker region populated by older stellar populations. We live in the thin disk, about halfway between the center and the edge, in a position that may have been crucial for the development of life on Earth. Our location in the galaxy isn't random. We orbit in what astronomers call the galactic habitable zone, a region where conditions are stable enough for complex chemistry to flourish. Too close to the center, and deadly radiation from the supermassive black hole and frequent supernovas would sterilize any nearby worlds. Too far from the center, and there wouldn't be enough heavy elements to build rocky planets or complex molecules. We exist in a cosmic sweet spot, protected by our position in the galaxy's suburbs. The space around our solar system is shaped by something called the local bubble, a cavity in the interstellar medium carved out by ancient supernova explosions. This region of hot, thin gas extends for hundreds of light years in all directions, creating a relatively clear window through which we can observe the rest of the galaxy. We may owe our existence to these long-ago stellar explosions, which cleared away dense gas clouds that might otherwise have disrupted our solar system's formation. As we orbit the galaxy, our solar system doesn't follow a perfectly flat path. Instead, it oscillates gently above and below the galactic plane, like a cork bobbing on ocean waves. This vertical motion takes us through different regions of the galaxy over tens of millions of years, occasionally carrying us through the plane where gas and dust are more concentrated. Some scientists speculate that these passages might influence long-term climate patterns on Earth. Though the evidence remains inconclusive, the Milky Way is still growing, still evolving, still writing new chapters in its cosmic story. Small satellite galaxies continue to fall into our gravitational embrace, their stars scattered into long streams that wrap around the galactic halo. These stellar streams are like fossil records of ancient mergers, preserving evidence of our galaxy's cannibalistic past. The largest of these ongoing collisions involves the Sagittarius dwarf galaxy, which is being slowly torn apart by the Milky Way's tidal forces. In the far future, our galaxy will look very different. The collision with Andromeda will create a new, larger elliptical galaxy that astronomers have already nicknamed Milkomeda. The night sky will be transformed as the two galactic cores merge and new bursts of star formation illuminate previously dark regions. But this cosmic collision won't be violent in any human sense. Individual stars are so far apart that direct collisions will be extremely rare. Instead, the merger will be a slow, graceful dance lasting several billion years. Looking even further ahead, the Milky Way's star formation will eventually slow and stop as the galaxy exhausts its supply of gas. The massive stars that currently light up the spiral arms will burn out, leaving behind only the smaller, longer-lived red dwarfs. These dim suns will continue shining for trillions of years, far longer than the current age of the universe. Eventually, even they will fade, leaving behind a galaxy populated only by stellar remnants. White dwarfs, neutron stars, and black holes slowly evaporating in the cosmic dark. But that far future is almost incomprehensibly distant. For now, the Milky Way remains in its prime, a mature spiral galaxy rich with ongoing star formation and teeming with possibilities. Every night, new stars ignite in distant molecular clouds. Every day, planets form around young suns. Every moment, the complex chemistry of life may be taking hold on worlds we cannot yet imagine. The galaxy that cradles us is both ancient and young, massive yet delicate, chaotic but ordered. It operates on scales of space and time that dwarf human experience. Yet it created the conditions that allowed consciousness to emerge and contemplate its own origins. In learning about the Milky Way, we discover not just our cosmic address, but our cosmic heritage, the deep connections that link us to every star in the night sky. Tonight, as you settle into this peaceful exploration, let your mind drift to the invisible architecture that shapes our galaxy. Beyond what we can see with our eyes lies a hidden realm of magnetic fields that thread through the Milky Way like an intricate web. These fields, though incredibly weak by earthly standards, stretch across thousands of light years and play a crucial role in how matter moves through space. They guide the flow of charged particles, influence how gas clouds collapse to form stars, and create beautiful structures that can only be detected by radio telescopes tuned to specific frequencies. The magnetic field lines twist and loop through the galaxy in patterns that mirror the spiral arms, sometimes rising high above the galactic plane in graceful arcs. Where these fields intersect with clouds of gas and dust, they can trigger waves of compression that ripple outward like stones dropped in a cosmic pond. These magnetic waves help regulate the pace of star formation, ensuring that not all of the galaxy's gas is consumed at once in a sudden burst of stellar birth. Between the grand spiral arms, where we make our home, lie what astronomers call spurs, smaller structures that branch off from the main arms like tributaries from a great river. Our solar system resides in one of these minor features, the Orion Spur, a relatively quiet stellar neighborhood that may have provided the stable environment necessary for life to develop on Earth. Here, far from the crowded inner regions and the sparse outer edges, we enjoy a kind of galactic middle ground, where conditions are neither too extreme nor too barren. The Milky Way breathes through processes that unfold over millions of years. Hot gas, heated by stellar explosions, rises from the galactic disk into the surrounding halo, cooling as it expands into the thin spaces between stars. Eventually, this enriched material falls back toward the plane of the galaxy, carrying with it the heavy elements forged in stellar cores. This galactic fountain recycles matter between the disk and halo, ensuring that each new generation of stars has access to the chemical ingredients needed to build complex worlds. As you rest tonight, cosmic rays are streaming through your body, high-energy particles accelerated by shock waves from ancient supernovas. These invisible messengers carry information about distant corners of the galaxy, having traveled for thousands or millions of years before reaching Earth. Most pass through you harmlessly, but occasionally, one will strike an atom in the atmosphere above, creating a cascade of secondary particles that rain down like cosmic confetti. You are constantly bathed in this gentle shower of galactic radiation, a reminder of your connection to the most violent events in stellar evolution. The center of our galaxy pulses with activity invisible to human eyes. Though dust clouds block our view of the core, invisible light, infrared, and radio telescopes reveal a dynamic region where gas spirals inward toward the central black hole. Sometimes this material falls in quietly, but other times it flares with intense radiation as matter is heated to millions of degrees before crossing the point of no return. The supermassive black hole at our galaxy's heart may seem like a cosmic destroyer, but it also plays a crucial role in regulating the growth and evolution of the entire galactic system. Surrounding this dark giant is a dense collection of stars, unlike anything in our local neighborhood. Here, stellar densities are thousands of times higher than in our region of space, and stars occasionally wander close enough to the black hole to be torn apart by tidal forces. When this happens, roughly half the star's material falls into the black hole, while the rest is flung outward at incredible speeds, creating a brief but brilliant flare that can be detected by telescopes across the galaxy. The Milky Way contains structures so large they dwarf our comprehension. Enormous loops of radio emission extend tens of thousands of light years above and below the galactic center, possibly remnants of ancient explosions or jets of material ejected by the central black hole. These Fermi bubbles, discovered only in recent decades, suggest that our galaxy's core was once far more active than it appears today. Perhaps billions of years ago, the Milky Way blazed like a beacon, its central engine fed by a steady stream of infalling matter. Throughout the galaxy, stellar nurseries continue their patient work of star formation. In the cold depths of molecular clouds, where temperatures hover just a few degrees above absolute zero, gravity slowly gathers gas and dust into ever denser clumps. These stellar embryos grow over hundreds of thousands of years, accumulating mass until their cores become hot and dense enough to ignite nuclear fusion. The moment of stellar birth is marked by powerful winds that blow away the surrounding cocoon of gas, revealing the newborn star to the galaxy at large. Not all stars are born alone. Many emerge from their natal clouds as part of multiple systems, binary or triple stars bound together by gravity. These stellar families evolve together, sometimes exchanging material as they age, creating exotic phenomena that single stars cannot produce. When one member of a close binary system reaches the end of its life, it may strip material from its companion, leading to nova explosions or the gradual formation of bizarre objects like white dwarf stars with helium atmospheres. The galaxy's disk is layered like a cosmic wedding cake, with different stellar populations occupying distinct vertical zones. The thinnest layer, where we reside, contains the youngest stars, and most of the galaxy's gas and dust. Above and below this active region lies the thick disk, populated by older stars with more elliptical orbits. These ancient suns formed when the galaxy was younger and more chaotic, their tilted paths preserving memories of gravitational encounters from the distant past. Even further out lies the galactic halo, a roughly spherical region containing the galaxy's oldest stars and most of its dark matter. Here, globular clusters orbit like distant satellites, each one a dense ball containing hundreds of thousands of ancient suns. These stellar cities formed in the early universe, when gas clouds were denser and star formation was more efficient than it is today. They serve as fossil records of the galaxy's youth, preserving stellar populations that are nearly as old as the cosmos itself. The space between stars is not empty, but filled with an incredibly tenuous medium of gas and dust. This interstellar material has been enriched over billions of years by the death throes of countless stars, creating a complex chemical soup that varies from region to region. Some areas are dominated by hydrogen and helium, the primordial elements forged in the Big Bang. Others are rich in heavier elements like carbon, oxygen, and iron, the products of stellar nucleosynthesis scattered by supernova explosions. Within this interstellar medium, chemistry unfolds on a scale impossible to replicate on Earth. In the cold depths of molecular clouds, atoms stick to dust grains and undergo reactions that would be impossible in warmer environments. Complex organic molecules form in these cosmic laboratories, including some of the building blocks of life. When new stars and planetary systems form from this enriched material, they inherit a rich chemical legacy that may have been crucial for the emergence of biology. The Milky Way's spiral structure is maintained by density waves that sweep through the galactic disk like traffic jams on a cosmic highway. These waves compress gas and dust as they pass, triggering bursts of star formation that light up the spiral arms with the blue glow of young, massive stars. the pattern rotates at a different speed than the stars themselves, creating the illusion of permanent structure, while individual stars drift in and out of the arms over millions of years. Our galaxy participates in a larger cosmic dance, gravitationally bound to dozens of other galaxies in the local group. The largest members of this cosmic family are the Milky Way and Andromeda, but smaller galaxies orbit around us like moons around a planet. Some of these satellite galaxies are being slowly torn apart by our gravity, their stars scattered into long streams that wrap around our galactic halo. The Magellanic Clouds, visible from Earth's southern hemisphere, may be newcomers to our gravitational family, captured only recently in cosmic terms. As you drift toward sleep tonight, remember that the story of the Milky Way is also your story. The calcium in your teeth was forged in the cores of massive stars that exploded billions of years ago. The iron that carries oxygen through your bloodstream was created in supernova explosions that enriched the interstellar medium with heavy elements. You are made of star stuff, literally composed of atoms that once resided in stellar furnaces scattered across the galaxy. The gentle rhythm of your breathing connects you to the cosmic cycles that have shaped our galaxy for over 13 billion years. Each exhale returns carbon to the atmosphere, carbon that may one day become part of a distant world. Each heartbeat pulses with energy, ultimately derived from nuclear fusion in the sun's core, the same process that powers every star in the night sky. You are not separate from the galaxy, but intimately connected to its past, present, and future. In the darkness of space, new worlds are forming around young stars, their surfaces still molten from the violence of planetary assembly. Some of these worlds may harbor the conditions necessary for life, adding new chapters to the ongoing story of cosmic evolution. The Milky Way continues to write itself across space and time, creating ever more complex structures and possibilities with each passing moment. Tonight, as you rest in the embrace of cosmic wonder, you are both infinitesimally small and magnificently significant, a conscious observer in a galaxy that has spent eons creating the conditions for awareness to emerge and contemplate its own existence, plate its own existence. The galaxy pulses with invisible rhythms that span millions of years, breathing in matter from the cosmic web and exhaling enriched gas back into the intergalactic medium. This galactic circulation carries the seeds of future worlds across vast distances, distributing the heavy elements created in stellar cores to regions where new planetary systems will eventually form. The process unfolds so slowly that entire civilizations could rise and fall between one cosmic breath and the next, yet it shapes everything we see in the night sky, deep within molecular clouds, scattered throughout the Milky Way. Complex chemistry unfolds in laboratories colder than the most remote corners of space. Here, atoms move so slowly they can stick together on the surfaces of microscopic dust grains, building molecules that would instantly decompose in warmer environments. Amino acids, the building blocks of proteins, form naturally in these frigid nurseries, along with alcohols, sugars, and other organic compounds. When these clouds eventually collapse to form new stars and planets, they carry this rich chemistry with them, seeding young worlds with the ingredients necessary for life. The magnetic fields that thread through our galaxy create invisible highways for charged particles, guiding their motion across thousands of light years. These cosmic magnetic rivers can accelerate particles to nearly the speed of light, creating the cosmic rays that constantly shower Earth from all directions. Some of these high-energy messengers began their journey in supernova explosions that occurred before our solar system even existed, carrying information about stellar deaths that happened in distant corners of the galaxy billions of years ago. Between the major spiral arms, smaller structures called spurs and segments create a complex web of stellar neighborhoods. Our own region, the Orion Spur, extends for thousands of light years, hosting not just our solar system, but countless other stars in their potential families of worlds. This local arm may have provided crucial protection during Earth's early history, shielding our developing biosphere from the intense radiation and gravitational disruptions common in the galaxy's more crowded regions. The Milky Way's outer edges fade gradually into the cosmic void, with no clear boundary marking where our galaxy ends and intergalactic space begins. Instead, the stellar density slowly decreases until individual stars become rare wanderers separated by enormous gulfs of darkness. Some of these outlying stars follow highly elliptical orbits that carry them far from the galactic plane, like cosmic comets with periods measured in hundreds of millions of years. They may spend most of their time in the lonely spaces between galaxies, returning to the Milky Way's embrace only briefly. During their long journeys, ancient streams of stars wrap around our galaxy like ghostly ribbons, the remains of smaller galaxies that wandered too close to our gravitational embrace. These stellar fossils preserve evidence of cosmic cannibalism that occurred billions of years ago when the Milky Way was actively growing by consuming its smaller neighbors. Each stream tells the story of a galaxy that once contained its own spiral arms, stellar nurseries, and perhaps even worlds where life might have emerged, all now scattered into long arcs of starlight that trace the path of their final orbital decay. The supermassive black hole at our galaxy's center exists in a delicate balance with its surroundings. When too much matter falls inward too quickly, the resulting energy release can blow away nearby gas clouds and temporarily halt star formation across vast regions. This cosmic thermostat helps regulate the galaxy's growth, preventing it from consuming all its star-forming material too rapidly. The black hole's gravity also shapes the orbits of nearby stars into rosette patterns that slowly precess over thousands of years, creating a complex gravitational choreography in the galaxy's dense core. Throughout the Milky Way's disk, stellar associations mark regions where groups of stars formed together from the same giant molecular cloud. These loose clusters gradually disperse as their member stars drift apart under the influence of galactic rotation and gravitational perturbations from passing objects. Our Sun was likely born in such a cluster billions of years ago, along with dozens or perhaps hundreds of stellar siblings that are now scattered across the galaxy. Some of these long-lost relatives may still shine in our night sky, indistinguishable from other stars, except for their shared chemical fingerprints and similar ages. The galaxy's rotation creates a phenomenon called differential rotation, where stars at different distances from the center orbit at different speeds. This cosmic clockwork winds up the spiral arms like springs, stretching and distorting their shapes over millions of years. Density waves propagating through the disk help maintain the spiral pattern despite this differential motion, creating regions of enhanced star formation that light up the arms with the brilliant glow of young blue giants and the red nebulae they illuminate. As our gentle journey through the Milky Way draws to a close, let your breathing settle into the quiet rhythm of cosmic time. Tonight, you've drifted through 13 billion years of galactic history, from the first ancient stars to the stellar nurseries still glowing in distant spiral arms. You've witnessed the invisible architecture of dark matter, felt the pulse of magnetic fields threading through space, and discovered your profound connection to the cosmic story unfolding all around us. Rest now, knowing that you are made of starlight and stardust, forever part of this magnificent spiral we call home. Sleep well and dream of the infinite wonders that await in our galaxy's endless dance through space.